In this video, I want to do a bunch of examples involving exponent properties. But before I even do that, let's have a little bit of a review of what an exponent even is. So let's say I had 2 to the third power. You might be tempted to say, oh, is that 6? And I would say, no, it is not 6. This means 2 times itself 3 times. So this is going to be equal to 2 times 2 times 2, which is equal to 2 times 2 is 4. 4 times 2 is equal to 8. If I were to ask you what 3 to the second power is, or 3 squared, this is equal to 3 times itself 2 times. This is equal to 3 times 3, which is equal to 9. Let's do one more of these. I think you're getting the general sense if you've never seen these before. Let's say I have, I don't know, 5 to the seventh power. That's equal to 5 times itself 7 times. 5 times 5 times 5 times 5 times 5 times 5 times 5. That's 7, right? 1, 2, 3, 4, 5, 6, 7. And this is going to be a really, 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 really large number. And I'm not going to calculate it right now. If you want to do it by hand, feel free to do so or use a calculator. But this is a really, really, really large number. So one thing that you might appreciate very quickly is that exponents increase very rapidly. 5 to the 17th would be even a way, way more massive number. But anyway, that's a review of exponents. Let's get a little bit steeped in algebra using exponents. So what would 3x, let me do this in a different color. What would 3x times 3x times 3x be? Well, one thing you need to remember about multiplication is it doesn't matter what order you do the multiplication in. So this is going to be the same thing as 3 times 3 times 3 times x times x times x. And just based on what we reviewed just here, that part right there, 3 times 3 3 times, that's 3 to the third power. And this right here, x times itself 3 times, that's x to the third power. So this whole thing can be written as 3 to the third times x to the third. Or if you know what 3 to the third is, this is 9 times 3, which is 27. This is 27 x to the third power. Now, you might have said, hey, wasn't 3x times 3x times 3x, wasn't that 3x to the third power? Right? You're multiplying 3x times itself 3 times. And I would say, yes, it is. So this right here, you could interpret that as 3x to the third power. And just like that, we stumbled on one of our exponent properties. Notice this. When I have something times something, and that whole thing is to the third power, that equals each of those things to the third power times each other. So 3x to the third is the same thing as 3 to the third times x to the third times x to the third, which is 27 to the third power. Let's do a couple more examples. What if I were to ask you what 6 to the third times 6 to the sixth power is? And this is going to be a really huge number, but I want to write it as a power of 6. Let me write the 6 to the sixth actually in a different color. 6 to the sixth times 6 to the third times 6 to the sixth power. What is this going to be equal to? Well, 6 to the third, we know that 6 times itself 3 times. So it's 6 times 6 times 6. And then that's going to be times, the times here is in green, so I'll do it in green. Or maybe I'll make both of them in orange. That is going to be times 6 to the sixth power. Well, what's 6 to the sixth power? That's 6 times itself 6 times. So it's 6 times 6 times 6 times 6 times 6. Let's see, that's 5. Then you get one more times 6. So what is this whole number going to be? Well, this whole thing, we're multiplying 6 times itself how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9 times, right? 3 times here, and then another 6 times here. So we're multiplying 6 times itself 9 times. 3 plus 6. So this is equal to 6 to the 3 plus 6th power, or 6 to the 9th power. And just like that, we've stumbled on another exponent property. When we take exponents, in this case 6 to the third, the number 6 is the base. We're taking the base to the exponent of 3. When you have the same base and you're multiplying two exponents with the same base, you can add the exponents.